All right, welcome to lesson P2. We're just going to be talking about solving equations, and we are going to do a little bit of word problems at the end. So let's get started. So the objective is we're solving equations. So hopefully this is some good review. Solution of an equation. Here's a definition for you. It's a number that makes the equation true. So when you solve an equation, you get x equals 3. It's the value of x that's going to make that equation true. In order to solve equations correctly, so what we're going to practice with the first few examples are the properties of equality. All right. First, seems almost ridiculous to say, but it's called the reflexive property. What that's telling you is what's on one side of the equation is equal to what's on the other side of the equation. There's the symmetric property, meaning you can flip the equation around. What's on the left side can go to the right side, what's on the right side will go to the left side, and it's still a true statement. You're going to utilize that if when you solve it, the variable that you're solving for is on the right and you want it on the left, that kind of thing. Transitive property, if A equals B and B equals C, then A also has to equal C. You will use that, the concept of that. By the way, most of this stuff, everything on this page, if you've solved equations, you've used it whether you know it was that property or not. The addition property, so all the next four are primarily the ones that you think of when you solve an equation. What that means is if you have already an equation that's true, A equals B, then if you add the same value C to both sides, it's still equal, right? If you add the same thing to both sides of an equation, it's still an equation. So that applies then to subtraction. If you subtract the same thing from both sides, it still works. Multiplication, if you multiply the same thing to both sides, it still works. If you divide the same thing from both sides, it still works. The only caveat is that you can't divide by 0. But you'll find that throughout everything we do. And then substitution property. All right, if A equals B, then you can substitute B out and substitute A in anywhere you want because they equal the same thing. All right, so that's something that you'll use probably more when we're talking about systems of equations, like when you're solving more than one equation. Hmm. Tell you what, we're just going to copy this to the next slide. All right. So we'll do A first, and then we'll do B. All right. So when you're solving an equation that has variables on both sides, you want to send all variables to one side, all numbers to the other side. So I'm going to subtract 8y from both sides. I'm also going to subtract 48 from both sides because I'm going to send the 48 to the right side. You can do this all in one step. You end up with 5y is equal to, that cancels out, negative 95. So you end up with y is equal to negative 19. Okay. On this side, almost the exact same thing. You're going to subtract 2x from both sides to send the x's to the left side. You're going to subtract 3 from both sides, send the 3 to the other side. 7x minus 2x is 5x. That's gone, and you end up with negative 15. Divide 5 on both sides, and you get x is equal to negative 3. Same idea, just a little more complicated. We're going to use the distributive property, meaning we need to distribute into the parentheses before we can then do those kinds of steps. Um, First thing I would do is distribute the -7. When I say -7, I'm including the negative sign in it. So now you have 3x. -7 times 2x is minus 14x. -7 times -13 is positive 91. Then over here, distribute the 3. 3 times -2x is -6x. 3 times 9 is 27. All right, we're going to combine the like terms there. And then it really just becomes what you did in the last example. So we're going to add 6x to both sides. Or subtract 91 from both sides. And you end up with -5x. That cancels, is equal to, let's see, well, 64, -64. All right, and then you're going to divide both sides by -5. And you get x is equal to 64/5. I'm okay leaving it like that. There's no need to turn something into a mixed number. Um, there's also no need to turn anything into a decimal unless there's context. So if you're just solving an equation, leave it as as an improper fraction. If you can simplify it, you need to simplify it, but there's nothing to simplify out of 64 and 5. All right, so this one, you will distribute the 4. So you have 4m plus 36. And then here you're going to distribute the -3. So -3m plus 12. Okay. Now again, same deal. Send all the variables to the left. So add 3m, subtract 36. Send the constant to the right. And you end up with 7m. Those cancel, equal to -24. All right, divide by 7, you get m is equal to -24/7. And again, that's okay. All right. All right, I'm sorry, literal equations. These are equations that have no numbers, but you're going to do the same steps that you would if there were numbers. So this one we're solving for d. The literal equation has to tell you which of the variables you are solving for. So we're solving for d, we're trying to get that by itself. So if you're trying to get that by itself, you look at what's happening to it. Right now, pi is multiplying it. So how do you get rid of something that's multiplying? You divide. Now you have c divided by pi is equal to d. Only thing I would do from this point is flip it around. Use the um, reflexive property and say d is equal to c divided by pi. All right. All you're trying to do, when it says solve for d, that means get d by itself. So for this one, we're solving for b1. So we're trying to get b1 by itself. We're trying to isolate that. First thing I would do is, the tendency would be to distribute in. I think it'd be easier to not, because once you distribute in, then you're going to have to divide it away anyway. So me, I think the easier thing to do would be to get rid of the 1/2 first. How do you get rid of 1/2? You can divide by that fraction, but there's no, to me, it's easier to think about instead of dividing by 1/2 to multiply by its reciprocal. The reciprocal of 1/2 is 2, so I want to multiply by 2 on both sides. All right, 2 times 1/2 is 1, so essentially that's gone now. Because 1h is the same thing as just saying h, right? So it's gone. Then I would divide the h away, because that h is multiplying where the b1 is. You could distribute it in. Again, it'll just be adding extra steps. Now you have 2a divided by h is equal to b1 plus b2. So I have b1 being added by b2, so we're going to subtract b2 from both sides. And then b1 is equal to 2a divided by h minus b2. All right, so again, just trying to isolate the b1. Last one here, we're solving for a. First thing I would do is get rid of the 8 that's adding. So now you have x divided by a is equal to b minus 8. What's confusing about this one is, since you're solving for a, you can't really do much with it in the denominator. Like, you can't just get rid of the x. So what we're going to do instead of getting rid of the x is we're going to move the a. Okay, so now the a is gone from the left side, and you have x is equal to b minus 8 multiplied by a. I want to get a by itself. The b minus 8 is multiplying the a, so we're going to get rid of that by dividing the entire expression b minus 8. And you end up with a is equal to x divided by b minus 8. Okay, so again, we got a by itself there. Right, at this point, um, we'll get back to finishing this note sheet. You don't need to finish this note sheet. You're simply going to start a practice that is just solving equations. So we'll do the second part of this at a later time. But right now we're going to stop taking notes. So this is just part 1 of the P2 notes. And I will assign a practice that you can either start today in class if you're ready, or start it tomorrow. When I say tomorrow, I mean Thursday. So today is Wednesday, tomorrow is Thursday. Okay. So good job finishing the notes. And we'll start the second practice now, the P2 practice part 1.